Hello everyone and welcome to my channel. In this video, we have a very interesting math challenge to solve. We are given 7 to power x minus 11 to power x all over the square root of 77 to power x minus 121 to power x is equal to 1. What do we know about this problem? We see clearly that the numerator divided by denominator is equal to 1. That means that the numerator is equal to the denominator. That is one thing we can notice. Another thing is that we may think that 7 to power x is less than 11 to power x, and such we should have a negative quotient. However, the denominator appears as if 7 to power x is less than 121 to power x, and therefore it looks like a complex number. But when we look at it properly, the quotient, that's the result of the division, tells us that 7 to power x is greater than 11 to power x, or that 7 to power x minus 11 to power x is greater than 0. Same thing can be said about the denominator. 77 to power x is greater than 121 to power x, or that 77 to power x minus 121 to power x is greater than 0. What do all these things mean? They simply mean that x is a member of the set of rational numbers. X is in fact negative rational number. For example, if I have 7 to power minus 1 over 2, it is greater than 11 to power minus 1 over 2. Therefore, we'll have a positive result at the right hand side. I am going to use two methods to solve this problem. The first method will stem from the fact that the numerator is equal to the denominator. This can be achieved by multiplying both sides of the equation by the denominator or by cross multiplying. In the second method, we are going to assume that the denominator is a complex number, and so we are going to use the conjugate of the denominator. Now let us start with the first method. In the first method, I said that I am going to multiply both sides by this, or cross multiply. If I cross multiply, I have 7 to power x minus 11 to power x is equal to 77 to power x minus 121 to power x, all of them in a square root. And the next thing is to square both sides to remove this square root sign. If I square both sides, I have 7 to power x minus 11 to power x raised to power 2 is equal to 77 to power x minus 121 to power x, all raised to power 2. This and this will cancel out, remaining 7 to power x minus 11 to power x raised to power 2 is equal to 77 to power x minus 121 to power x. If I continue the process like this, it will look wieldy and cumbersome. So what I need to do is to make a substitution. We will let 7 to power x is equal to a, and 11 to power x is equal to b. But before we apply this, let us rewrite the right hand side. 7 to power x can be written as 7 times 11 all to power x, and therefore we have 7 to power x times 11 to power x. In this case, what we did is to apply a property in indices. A times b all to power c can be written as a to power c times b to power c. In this case, that is 1 to 1 to power x, it can be written as 11 to power 2 all to power x, and we can write it as 11 to power x all to power 2. In this case, we apply a to power b to power c is equal to a to power c to power b, more like the powers exchange position. Now let us apply these substitutions, having these things in mind. So we have a minus b to power 2 is equal to ab minus b squared. Now if we open these brackets, we'll have a squared minus 2ab plus b squared is equal to ab minus b squared. Let us now move this part of the equation to the left hand side. So I have a squared minus 2ab minus ab plus b squared is equal to 0. So a squared minus 2ab minus ab plus 2b squared is equal to 0. We now have a quadratic equation. If we group them, we can factorize. In the first bracket, a is common, remaining a minus 2b. In the second one, minus b is common, remaining a minus 2b is equal to 0. Let us take one of these two brackets that are the same, a minus 2b in a bracket, and then put these other ones in a bracket, a minus b is equal to 0. So we now equate each bracket to 0, or a minus b is equal to 0. So a is equal to 2b, or a is equal to b. In the first case, we have a is equal to 2b. In the second case, we have a is equal to b. Let's remember that our a is 7 to power x, and then b is 11 to power x. 7 to power x, 11 to power x. So let us divide both sides by 11 to power x. This and this will cancel out. This will cancel this one, remaining 1. Here 2 is remaining. So 7 over 11 to power x is equal to 2, or 7 over 11 all to power x is equal to 1. I applied another property of indices in this case. If I have a over b all to power c, it can be written as a to power c over b to power c. This property is applied in this case. So I have an index equation or an exponential equation. We want to convert this to logarithm. For that to happen, we are going to take log of both sides in both cases. So if I take log to be 7 over 11, 7 over 11 of x is equal to log 7 over 11 as base of 2, or log to base 7 over 11, 7 over 11 of x is equal to log to base 7 over 11 of 1. Now, in logarithms, this is the power. It will come here and multiply the base. So I have x log to base 7 over 11 of 7 over 11 is equal to log to base 7 over 11 of 2, or x log to base 7 over 11 of 7 over 11 equals to log to base 1 of 7 over 11. Now, log to base a of a is equal to 1. So I will apply this here. X is equal to log to base 7 over 11 of 2, or x is equal to log to base 7 over 11 of 1. Now, log to base any number of 1 is equal to 0. So in this first case, x is 0. In the second case, we are going to rewrite it as x is equal to log to base 10 of 2 over log to base 10 of 7 over 11. What I did here is change of base. In change of base, we are given that log to base a of b can be written as log to base n of a over log to base n of b. So this is applied in this first case. We are now going to apply subtraction law of logarithm. So this 7 over 11 can then be written as log to base 10 of 7 minus log to base 10 of 11. So I have x is equal to log to base 10 of 2 over log to base 10 of 7 minus log to base 10 of 11 is equal to minus 1.53359. So x is minus 1.53359. So we see x is a member of the set of negative rational numbers. Now for the second method, we are going to assume that the denominator is a complex number. That is, we don't know that this quantity is greater than this quantity, and so we think this is a complex number. We are going to multiply the numerator and denominator by the conjugate of the denominator. But what is the conjugate of the denominator? If I have a minus b as a square root, the conjugate will be a plus b. So the conjugate of this is 77 to power x plus 121 to power x. I'm going to multiply the top, that's the numerator and denominator, by this conjugate of the denominator. It becomes 7 to the power x minus 11 to the power x all over the square root of 77 to the power x minus 121 to the power x times, let's multiply now by the conjugate. This is 77 to the power x minus 121. This is plus, please. 121 to the power x all over 77 to the power x plus 121 to the power x is equal to 1. Let us remember our substitution. 7 to the power x is a and b is 11 to the power x. So here is a minus b over here is square root of ab minus b squared times square root of ab plus b squared over ab plus b squared is equal to 1. I'll have a minus b in the brackets, ab plus b squared when I multiply the numerators, and then here becomes ab squared minus b squared squared. This is difference of 2 squared, and let us remember there is a square root sign there, then it's equal to 1. Next thing for us to do now is to square both sides. If we square both sides, here is a minus b all squared, and here is ab plus b squared, because the square will cancel the square root sign. All over, this square root sign will disappear, remaining ab minus b squared squared is equal to 1 squared is 1. So I have, if I proceed, a minus b squared, ab plus b squared all over ab plus b squared in a bracket and ab minus b squared in another bracket is equal to 1. This and this will cancel out, remaining a minus b all squared all over ab minus b squared is equal to 1. B is common in the denominator, so if we bring it out, a minus b squared over b rather than a minus b, where this will cancel one of these is equal to 1. So we now see we have simplified issues. So I have a minus b over b is equal to 1, and so a minus b is b. Bring this one here, I have a minus 2b is equal to 0. Let's remember that one of the solutions we have in the first method is that a is equal to 2b. So we have successfully eliminated that part where x is equal to 0. And so 7 to the power x is equal to 2 times 11 to the power x. Divide by 11 to the power x. Then we have 7 over 11 to the power x is equal to 2. And x, like we had earlier, is minus 1.53359. Now, if we back substitute minus 1.53359 for x, we are going to get 1 as the result of the division. I would like you to like this video if you find it interesting, subscribe to my channel if I haven't done so, and also leave a comment in the comment section. There are many other interesting videos on math problem that I have uploaded. You can do well to check them out in my channel. Thank you very much, and see you in another video.